就可以了。
Hi everyone. Okay, let's start. Okay. We can start our talk, and I'm really happy to give you this talk. There has been so many amazing agent applications. For example, we have coding agent in the previous talk. And so how about write your own agent applications? That's the topic of our this talk. Okay. So whether you are interested in LLM agents or just curious about Dongjie, this is our new programming language. So in this talk, I will give you some useful information about how to write agents easily using our agent framework named Magic. So this talk covers three parts. And first, we will give you some background about LLM agents and Dongjie. And especially, we will introduce the Dongjie programming language because I think most of you do not know what is Dongjie. And then we will write some and develop some real agent applications via CangjieMagic. And finally, we may dive into more details and the design of our framework. So now, I think most of you may be more familiar with agents than me. And even though there has not been a formally defined of LLM agents, but there are some widely accepted concept of the LLM agents, and I cited from the Lily Wang's famous blog. That is, agents, just for short in this talk, agents use the LLM as its brain, and it uses large language models to make some useful plans. And according to the plans, it may use some external tools to interact with the environment. For example, it can search the web, it can read some files, and do something more powerful. And more importantly, agents is able to remember it can remember and learn from past executions, so it can become more and more powerful. And now we have Dongjie, the new programming language. We hope use this new programming language help developers to write these powerful agents more easily. And let me introduce something about what is Dongjie. Dongjie is a new application level development programming language, which is developed by Huawei Programming Language Lab. And it has a powerful type system, a powerful macro system, and so it's fast and safe and reliable. And we use its macro system to develop agent DSL, and it's the main feature of our framework. So don't worry, you don't have to be a Dongjie expert. I will give you some basics to understand the code snippets in this talk. Because many other modern programming languages have similar features and syntax, so I think it's rather trivial to understand these code snippets in this talk. First, this code snip shows how to define a function in Dongjie. Okay, I think it's trivial to understand because just like any other programming languages. And we can group multiple functions and encapsulate data with functions as method, and this is a class. The interesting part is that Dongjie supports macro system, and it's something like annotation in some other programming languages, for example Python and Java. But macro is more powerful because it can transform any ASD to whatever you want. If you have experienced Rust, you will know it. And if you don't, you can have a try, and then you can try Dongjie to experience the power of macro system. And it's the basics of our agent DS. And finally, there's some primitive types. For example, string integers, and we can compound primitive types as more compound type structures. And Cangjie supports various expressions. And actually, in Cangjie programming language, everything is an expression. For example, we use the for loop, and it's for expressions. Now, that's all the basics to understand code. So we can move to the fun part and the core part of our talk. So how can we build some real agent applications? For example, I want to build a
你过来一点，这样子的话声音会大一点，就站到屏幕里
好
面去。
站那边。好，OK。
这样你想听什么？
哦，OK。Speak louder.
影响声音大。
OK. Can you hear me more clearly? OK. So time to move on to the fun part of our talk. Let's make some real agent applications. For example, I want to build a file assistant. It can help me count the number of files stored on my file system, or help me convert some files. So how to do it? That's all the code of this agent. So we can analyze it line by line. First, we use the macro agent. Oops. Oh, okay. The laser pointer is not useful. So we have the agent macro, and it's put on a class definition. So in this way, we can transform this class type as an agent type, and we inject some useful method to this class type, and we will use it later. And then for this agent, we can configure which chat model it uses. And here we use the DeepSeek chat model. Then we select an execute for this agent. The execute is the plan strategy the agent uses, and it guides how an agent to solve its tasks. For example, the famous React is a plan strategy, and in our framework, it's an React execute. And React guides the agent to solve tasks step by step with thought and with tool selection, and call this tool, and it continue to loop until the task is solved. And similar, we use the plan React here. That means the agent will make a plan of the whole task and continue to run, and we will illustrate it later. Then the agent has two fundamental elements, and then we can put more useful tools the agent can use. In this way, the agent can interact with the environment. And nowadays, MCP servers are so popular. So we introduced the MCP DSL syntax for configure which MCP servers it can use. And we select two here. The first one is Markdownify MCP server, and the second is the file system MCP server. And since both these two servers support SDDIO transport, so we configure them like this. It's just like a function syntax, but actually it's not a function. It's not a function of code. And inside the agent definition, we use another useful macro, that is prompt. In the prompt scope, we can write any string as the system prompts of an agent. And to help greenhats to write well-formed prompt, we introduce the prompt pattern. And here we use the ERA prompt pattern. So which means you have to write the expectation of your agent and the role of your agent and which actions your agent should to do. And in this way, the whole agent is complete. Now let's drive it to run. Okay. For example, we can give it a task that help me convert all PDF files to Markdown files. And we call it via the async chat API. In this way, the agent will make a plan because we set it with the plan React execute. So the plan means it will divide the task as multiple subtasks. And for each subtask, it will use the famous React executor to solve them. And finally, answer is summarized. And then the final answer it is output as a string. That is, we can use the for loop to get each chunk of its final answer and print it directly. So, and now, if you have used some real agent applications, you may have the question that there is still a gap, because real agent applications may display its immediate execution steps. So you can observe how and which some useful information of the agent execution. So to alleviate the burden of display developing such a task, we abstract the intermediate information of execution as a text string. That is, we use different tags to wrap some useful information. For example, we use the plan tag to wrap the actual plan generated by the agent, and we use some action tag, means it selects which MCP tool. And we have other more tags, for example, observation, final answer, and so on. And we introduce the visitor pattern here. In this way, you can develop your own visitor to display all these intermediate execution information. For example, you can develop a console printer. In this way, we can have this demo. Still, we give the same question as the previous slide. And when the agent runs, it will develop all its intermediate execution steps wrapped by these tags, and we display these tags with different colors. And you can have a better user experience, and just like some existing agent applications. And use with the same way, you can develop your agent applications on different platforms. For example, your mobile phones, your PC apps. And actually, internally, we have built a Magic agent application on Harmony OS, because Dongjie is designed for Harmony OS, though it supports multiple other platforms. And on Harmony OS, our agent combined with the Harmony OS system calls more tightly. But we will open source the application later. Okay. Now, we have developed a whole agent application, and let's move to another example. In this example, we want to build another kind of agent, and this agent not only just automate solving my tasks, it just retrieve some useful information from my document and answer my questions. That is some RAG agent applications. So similar to the previous agent, but it has a key difference is that it has the RAG attribute. And in this RAG attribute, we specify two values. The first one is source. And this means data source it will retrieve from to answer user questions. And the second is the mode. The mode has two options, static or dynamic. Here, static means when execute, the agent will always retrieve some related content from the data source and use retrieved content to answer user questions directly. And if you specify dynamic, it will treat the retriever just like a tool. And during its execution, it will decide when and how and which query to retrieve from the data source. Actually, the whole execution is that when the agent is initialized, it will split the markdown file and add chunks and use the embedding module to embedding these chunks and save all the information in a vector store. And when it accepts user questions, it will retrieve from the vector store and make a summary to answer your questions. And this is a simple usage. If you provide more complex data source, we will recommend you use more complex RAG algorithms. And our framework have also provide some graph RAG algorithms, but we do not introduce it in this talk now. You can refer to the project for more details. Okay, now, suppose you have developed multiple agents, and we have a file assistant. It can help us make some file conversions and access local file storages. And we have another QA bot, and maybe we have another agent that is able to generate some PPTs or more agents. How can we combine them all together and to build a full-fledged agent application? So we can use the agent DSL again. This part means multi-agent cooperation DSL. And we will introduce more detail later. But in this example, we just use leader cooperation, and we select to use the dispatch agent. This is a built-in agent provided by our framework. And when the agent group combined by the leader cooperation when this group accepts using questions, it will make a request dispatch. That is, it will deliver the user question to a concrete agent and use this agent to answer user questions, just like what we have discussed in previous two examples. Okay, now we have developed 3 different agent applications, so we can make a brief summary now. And using Changjie programming language, we developed our simple agent DSL. And this DSL helps us to develop single agents simply. And also, it can help us cooperate multiple agents simply. The main purpose of our agent DSL is to reduce boilerplate code as soon as possible. And we have full-fledged components to develop real agent applications. We have synchronous or asynchronous chat APIs, and we have components to help you to display agent intermediate execution informations. So if you are still curious about CangjieMagic, you can have a try to visit its website. Now, we can move to the a little bit boring part. That is, we have to dive into the magic framework, not just develop some real AI applications. So how we design and how CangjieMagic works. And actually, from an overview, CangjieMagic has 2 layers. The first one is the programming interface, and this is the agent DSL we have shown in previous slides. And the underlying CangjieMagic is used to support the DSL to run. And it has multiple modules. For example, it has planning modules, it has memory modules to support the RAG and the conversations. It has tool modules to manage all the tools and connect to the MCP servers, and it has more powerful runtime modules. And with this architecture, CangjieMagic, we hope it has 4 features. The first one is efficient development, because we hope the agent DSL offer a declarative agent programming interface, and it helps you to transform whatever you want an agent into simple Changjie code. And the second is that MCP servers are popular and widely used nowadays, and we use unified tool access syntax, still based on the agent DSL, but we have unified tool access syntax to develop and set different tools to agents. And agent has smarting planning strategies, and you can even develop your own plan strategies. And all the framework is highly flexible and extensive. And we will introduce these features one by one. Now, first again, we have to emphasize the agent DSL again. And DSL powered agent programming because we support one-liner configure for chat models and planning strategies. And we hope we use proper patterns to guide developer write better prompts and make the agent run efficiently. And still, we have more powerful agent DSL syntax. For example, we can maintain the conversation automatically. In this way, we support the agent with multi-round conversations, and we have multiple agent cooperation DSLs, and we have 3 different cooperation modes. The first one is linear group. That is the linear cooperation. It is trivial to understand. That is, all these agents execute one by one, and the previous agent generates its output at the input of the next one. And we have the leader of cooperation. This cooperation has been used to build our multiple agent applications. That is, a leader application is responsible for solving user questions, and it may decide when and how to communicate with other agents, that is, member agents. But member agents never communicate with each other. And more freely, we can have free group. That is, all agents can communicate with each other, and they communicate via a broadcast way. So that's some main features of agent DSL. And we have unified to access syntax. That is, we hope the agent with different tools can be more powerful. And we support the agent with different MCP servers, and these MCP servers have different transport. For example, STTIO's transport is write in this way. And even we can write CangjieMagic or Cangjie native functions as tools. And we also abstract these tools as a phantom MCP server. That is, we use the tools like a native function tool transport. And in this transport, we can set all these Cangjie functions the agent can use. And we also support HTTP, and even you can develop your own transport of MCP servers. And more interesting is that the syntax also support to develop your own MCP servers, just like some other framework, for example, FastMCP. In this way, you can use the tool. You use the tool macro to define your own tools and group all these tools as a whole MCP server. And during the runtime, we have a tool manager module. This module will automatically select proper and related tools from all available tool sets. And it composes these tools and use the plan strategy to drive the agent to solve the question. Okay. Now, we know that the plan strategy guide how an agent to solve tasks. So it's important for an agent, but still, write an efficient plan strategy is somehow it's a little bit hard. And we offer 2 approaches for writing the plan strategies. One is we offer one-line configuration for built-in strategies. That is, you just write one line of code, and you can use our predefined plan strategies. And more interesting, our DSL will support developer your own plan strategies easily. and we abstract we abstract many common and basic plan operations from common planning strategies. For example, we abstract from these strategies as think, act, and reflect, and so on. And then we can use our DSL to compose these basic operations as your own plan strategies. For example, this way we can develop your own React plan strategy. And also, this new feature is still work in progress. It is still work in progress internally. We will public it later. And finally, all the runtime modules can be extended by the agent DSL. For example, you can develop your own chat model and register this model, and then you can configure your developed model just use with the agent DSL. So the executor and the retriever can also be developed and customized. Okay, so that's all 4 features have been discussed, and we can make a conclusion that CangjieMagic may give developers first the simplest. That is, you can build agents in hours with our agent DSL, and all these agent is powerful from simple QA agents to multiple agent systems to automate solving complex tasks. And since Dongjie supports multiple platforms, so you can deploy all these agents developed by CangjieMagic anywhere. And especially with HarmonyOS,